Okay, shall we start? Okay. So today we cover part 3 of chapter 2, pressure and fluid static. So we cover 2.1. Let me have my pen. Okay, this or 2.1, 2, 3, 4, we all done it. You can refer back to the videos, how you can do the tutorial, the example of tutorial as well. I will post also the tutorial on curve. I have received a new tutorial on curve, so I can share with you, so you can do it on your free time. So today we are covering this sub-chapter 2.5, which is buoyancy and stability. But in this class today, Sunday, we only cover one of it, which is buoyancy. And the next class on Tuesday, we cover the stability. So we can wrap up all this chapter 2. Alright? Okay, buoyancy, I think is much simpler. It's much straightforward compared to the one that you have learned before on the hydrostatic force on curve. It's more complicated. But buoyancy, this topic, I think is very easy. It's very easy to understand and easy to calculate any problem lah. Okay, basically buoyancy kan apa? Keterapungan, daya apung. So the buoy and ship are obviously designed to float, obviously. So you can consider any kind of boat or raft or any other floating object that is expected to maintain a particular orientation when placed in a fluid. A body in a fluid, whether floating or submerged, is buoyed up by a force equal to the weight of the fluid displaced. And ni prinsip Archimedes, Archimedes principle. I think we have learned it before in secondary school. I'm not sure. Is it secondary school or?
Yes, form 5.
Ada ya?
Yes, sir.
Form 5.
Yes, sir. Secondary school.
Physics.
Sem first pun ada. PHY.
Sem first.
Ah.
Oh, okay. So we have learned it in the secondary school, and also you have learned it in your first semester. It's very basic. Anybody in a fluid, whether floating or submerged, is buoyed up by a force equal to the weight of the fluid displaced. Ini contoh apa? Gambar rajah lah. So ni apa, body yang masih belum disubmerge. So when the body start to submerge in the fluid, so this volume of displaced fluid will the same with the weight of the submerged body. Okay, and if they submerge fully, so the volume of this body which submerged in the fluid will be equal to the weight of this fluid displaced. So very straightforward lah. I will not elaborate more on this. Okay, so ini basic lah. Ini Archimedes principle ni basic dalam this topic, buoyancy. So you understand this, then you can answer all this question lah and buoyancy topic. So buoyant force, the upward force a fluid exert on a body, ni yang dari sini ni, ni immersed in it. The buoyant force is caused by the increase of pressure with depth in a fluid. Okay, so how you can find this FB? FB, okay, is a net of satu yang ni F bottom, satu lagi F top. So net of this F bottom minus F top, you can find your value for the buoyant force, FB. So how you calculate this? So this rho of the fluid dalam ni, in the fluid dalam ni, apa-apa fluid lah, water ke oil ke apa-apa. So rho of the fluid times the gravity times S plus H. How you get S plus H? So this is the distance of the free of the fluid of this body plus this another distance here, height here. So this is at the bottom lah, S plus H times A times the area of this body minus the one on against direction. So rho of the fluid, similarly the G sama the distance S lah, dia atas ni kan, so dia kan kat bawah kan, atas ni je, so S lah times A. So if you write it in the full equation, you got rho GSA plus rho GHA minus rho GSA, so you can cancel out one S kan, so only left with you rho GHA, rho of the fluid GHA, and which this HA also can translate in a volume, rho GV kan, because you know is sama dengan fluid volume yang displaced kan, actually this principle. So you can have your equation formula sama rho GV, so the buoyant force equal to rho GV, so that's how you can calculate lah, find your buoyant force. So this is the theory. When you look in the example, you will more understand how you calculate that buoyant force. Okay. Alright. So the buoyant force acting on a solid body, this is a solid body submerged in a fluid, and on a fluid body on the same shape, and maybe ini satu lagi same shape, at the same depth are identical. Okay, the buoyant force FB yang akan sentiasa ke atas lah, dia akan melawan act upward through the centroid of this body, centroid solid ni C ni, of the displaced volume, and is equal in the magnitude to the weight W of the displaced fluid, macam this principle, but is opposite in direction. Okay, for a solid of uniform density, its weight W S also acts through the centroid, but its magnitude is not necessarily equal to the depth of the fluid it displaces. Here WS ni is bigger than W. Okay, this WS is bigger than FB, the buoyant force. This solid body would sink. Ada if your weight of the body is bigger than your buoyant force yang against direction, that means the weight is higher, and then it will sink lah. The buoyant force tu tak mampu nak tolak dia terapung. Okay, so if you have this weight bigger than this buoyant force, that means the body would sink and goes to the floor lah, go to the floor of this tank or whatever. Okay, so this is actually this principle. The buoyant force acting on the body immersed in the fluid is equal to the weight of the fluid displaced by the body. So kita pun dah faham dia tu, and it acts upwards through the centroid of the displaced volume. So itu teori dia. We will not go much on the theory, because you will understand better when you do the example. Okay, so this is the three scenarios lah. In a fluid, you have one floating, okay, because of the rho of the body, the object is less than the rho of the fluid. That's why this body floating. The second one, the body, the object is suspended, is submerged, but still there. I mean, maintained at that level. Okay, so that means the rho of the object is equal to the rho of the fluid. Okay, so it's suspended body and it's already buoyant. And the third scenario, which have the rho of the body of the object is larger than the rho of the fluid, that means the object will sink until the beneath of this floor lah. So you have three scenarios, and in the question might be they will ask you different scenarios lah. Okay, so a solid body drop into a fluid will sink, float, or remain at rest. So satu float, satu remain at rest, satu lagi sink at any point in the fluid, depending on its average density relative to the density of the fluid. Okay, so that's basic lah, I think. Maybe one benda yang sangat berat, kalau dia lebih daripada density of the fluid, the object will sink. Example, maybe you have a very large concrete, very heavy concrete, and if you place in the water, the displaced water tu, yang di displaced tu tak mampu tak sama dengan berat of the fluid of the object, so the object will sink. Okay, alright. I think the theory is very simple and very short. There's not much component horizontal or vertical, so you just have to know summation of force lah. Summation of vertical force must be to 0, and you know this force equal to the weight of the displaced fluid, and so very, very basic. That's why only one class should cover this topic lah, buoyancy. Okay, okay, so we can go to the example to see how we can answer any question on buoyancy. So if you look at this example, I take it from the notes, from the whole notes. I think I've given to you in the classroom, the PDF file. So example 9, okay, it said a crane is used to lower weights into the sea. They give you the density of the sea water for an underwater construction project. Determine the tension in the rope of the crane due to a rectangular concrete block. So they give you the dimension of the concrete block, 0.4 meter, 0.4 meter and 3 meter, and they give you the density of the block, 2300 kilogram per meter cube. When, okay, first scenario, when it is first suspended in the air, so it's not submerged in a fluid, and B, completely immersed in water. So this is completely immersed dalam air. Okay, alright. So we go through lah. Okay, this is basically your FBD lah, your free water diagram. So you still need to draw your free body diagram. So this diagram for first scenario lah, which is on the air, dia kata suspended in the air, so it's not going to in any fluid. So for your body, for your object, so you have one component of force, which is the weight of the concrete going down, okay, and you have the rope lah, the rope yang angkat dia kan, the rope yang tahan dia, which is the FR, and this one. Okay, okay, so only that two, and because it's suspended in the air, so there's no buoyant force, and because we are not in the fluid, it's just on the air, so you know the summation of forces vertical, so vertical, and kalau you take this put positive, so FR minus W equal to 0 lah. Okay, very straightforward. So that's why you have the FR equal to W, and your W you can know from rho GV, kan? Rho GV. Okay, this is W, rho GV. Okay, so you know the rho of the concrete given it to you, which is 2300. You know the G constant, and you have the V, and the V of volume of this concrete block. So you know 0.4 times 0.4 times 3 lah. So this is V of the volume of the concrete end. So you have the all values you have, so you can calculate easily lah. Okay, 2300 times 98.81 times 0.48. So you give you day times 1/1000 because they want to change in kilonewton. So don't get confused. What is this? It's just divide by 1000. You get a value in kilonewton. Okay. So you get a value for FR or W, which is 10.8 kilonewton. So that's settled for scenario A. That's how you answer your question A. And B, for this is B. Okay. So when the concrete is fully immersed in the water, okay. They give you sea water, kan? So don't be careful with this, because they say in the sea, and the density of the sea water is 1025. Okay. Okay. Similarly, you have you need to draw the FBD, and you need to label so your W and your FR for the rope, force by the rope, and you have one more component of force, kan? since this concrete is immersed in the fluid, as we know, whenever a body is immersed in fluid, there must be a buoyant force acting through the centroid end, and this buoyant force is equal to the weight of the displaced fluid. Okay, that's why you have to add another term here, the FB, which against direction dia adalah upward. Okay, so when you write the equation, summation of force again, okay, that upward is positive, okay, equal to 0, so you know FR, okay, minus W plus FB equal to 0. Okay, so FR equals to W, sorry, equal to W minus the buoyant force, FB. Okay, so W you already find it, and 10.8. So now you need to find FB, okay, the buoyant force. Sama juga FB, and you know FB, how to find it, it's rho GV lah, rho GV, okay, rho of the fluid, because inside the fluid this one, okay, rho of fluid, I put it back, fluid, the G is constant, and the V, the volume lah, the volume of this concrete lah, because dia sama je kan dengan displaced volume of displaced water kan. So you have the rho of the fluid, which is 1025, you have the G 9.81, and you have the V 0.48. Okay, so now you have the value for FB, which is 4.8 kilonewton. Similarly, they also divide by 1000 to put. You have to be consistent lah. If you in the first step you use Newton, so in the second step you must use also the Newton. So you will be consistent. This is 4.8 for your FB, and now you can find your FR lah in this scenario. So FR equal to W minus FB. W is 10.8, FB is equal to 4.8, and we give you 6 kilonewton. Okay, so that's your the FR going upward with 6 kilonewton value. So that's so because they want to ask you to determine the tension, the tension in the rope, okay, of the crane. That's why you have to find this tension of this rope. Okay, so that's it's very easy kan, sangatlah simple. That's why I said to you from the beginning, this topic should not be a problem, should not be too difficult. It's very basic vertical force and summation of force, find your weight of the displaced fluid and everything lah. So I'm not too worried about this topic. I think all of us can understand it well and can do the question correctly lah. Okay, so buoyancy material, ni benda pun ni lah, material yang kita guna untuk buat anything yang kita nak dia float kan. So normally people will choose the material will have a specific weight, low specific weight and density, and it has little or no tendency to absorb the fluid. Maksudnya plastik ke kan. Kalau tak, kalau dia absorb akan jatuh lah, dia akan tenggelam. Compatibility with the fluid in which it will operate. Kalau lah fluid tu dia guna mercury ke kan, maybe different fluid, so the material should be fine with that fluid. So ability to be formed to appropriate shapes, ability to withstand fluid pressure to which it will be subjected, and abrasion resistant and damage tolerant. So normally when any engineer design a buoyancy material, they will consider this characteristic lah. But people will say, maybe some of you will ask, how about the ship and kapal? The ship has very high specific weight and density kan, but still ship is made to float on the water. So that's where Archimedes principle comes in kan. How ship will float, they just displace the fluid. Untuk memastikan kapal tu boleh sentiasa terapung walaupun dia berat kan, because they displace the fluid beneath the ship kan. So if they want to go deeper, maybe they want to transport a lot more weight. You see a lot of big ship bring a container. So if they put any additional weight, the ship will go down and displace more fluid. So that's to remain buoy on the sea, terapung on the sea. But if they add weight beyond that, beyond the capability of the ship, and they will sink lah. Okay, that's the principle of Archimedes. So that's why if you curious lah how ship is float, I think that's a basic understanding how things float. Sometimes some of the material might have a hollow hollow area in that body, so they can float as well. Macam buah kelapa buah kelapa can float. Why? Because they have inside of the kelapa there are some area and hollow area, so that area helps the coconut to remain buoy in the water, even though they are heavy. Okay, so we look another example 10. So a cube of 0.5 meter. So the cube, cube, so 0.5, 0.5 and 0.5 on the side is made of bronze, the material is bronze, having a specific weight. So they give a specific weight, which is Y, the symbol of 86.9 kilonewton per meter cube. Determine the magnitude and direction. So they ask you to determine the magnitude and how many newton or whatever, and direction. So whether it goes down or the force goes up, in which direction of the force required to hold the cube in equilibrium completely submerged. Satu, in water, okay, and B, in mercury. So there are two scenarios. One, completely submerged in the water, and B, completely submerged in mercury. So they ask you to find the magnitude and direction of the force required to hold the cube. Okay, so they give you the specific gravity of mercury is 13.54. So they give you the SG. So you know how to change this in row. Okay. Okay, so this we go through by one by one. Start from this note. Okay, so now we consider part A first lah, on the water, completely submerged in water. Okay, you have to draw your FBD of that cube and label all the water, all the force acting on the cube. Okay, on the assumption that the bronze cube will not stay in equilibrium by itself, some external force is required. So you don't know. We just assume that the bronze will not stay in equilibrium by itself. That means some external force is required. Maksudnya force yang atas tu diperlukan. The objective is to find the magnitude of this force and the direction in which it would act, that is up or down. Now step 2 of the procedure before looking at the next panel. So this is the diagram. So this is your, if you want to answer this question, you need to draw the FBD lah. Okay. So this is the 3-dimensional and this is the 2-dimensional. Okay, they ask you to find the magnitude of this force, Fe ni. The magnitude and also the direction, whether the direction is upward or downward. So they ask you to find that. Okay. So that's why they say here, in this one, on the assumption that the bronze cube will not stay in equilibrium by itself, okay, that means some external force is required lah. Okay, that's why we need this Fe. Okay, so don't worry about this arrow whether it's go up or down. Okay, you just assume one. So just say we take upwards, because they ask you to find which direction. Okay. So in this FBD, you just draw in any direction, and when you calculate the value, that value will tell you whether the direction is true or not. Okay. So your assumed assumption is the Fe goes up, Okay, and now we do the calculation and see and verify whether the direction is correct or incorrect. Okay, you have the FB, the buoyant force acting upward. That is memang macam ni lah the buoyant force is always acting upward through the centroid. And you have the weight of the concrete going down lah. Okay, this two will not change lah. The buoyant force will goes up, the weight will go down. The one that change maybe this external force lah, whether it goes up or goes down. Okay, the equation, so this sama lah, summation of force vertical, summation of force in vertical direction must equal to 0. So because you assume the FE go up, okay, that's why you have FB plus FE. So FB plus FE, the same direction, minus W, because W go down in the opposite direction, equal to 0. So this is your first equation lah. Okay, and you want to find FE, and they ask you to find FE, the external force. So you rearrange the equation. So the external force is equal to W minus FB. Okay, ni semua ada kan? Dengar kan?
Dengar saya, dengar.
Ada.
Okay, I just checking
Saya.
saya takut saya terkeluar seorang-seorang, saya kata seorang-seorang. Okay, right. So understand okay, so you rearrange the equation. So FE equal to W minus FB lah So simple kan. Okay, now you want to find FE kan. You need to find W and also FB lah. So how do we calculate the weight of the cube? It's simple, and you know they give you the specific weight. They give you the specific weight, 86.9 kilonewton. Okay. So from there, you can find the weight lah. Okay. The specific weight times volume equal to weight of the fluid of the body lah. So you know the volume of the concrete, which is 0.5 cube, because it's a cube. 0.5 times 0.5, 0.05, will get you the V, and they give you the specific weight. So specific weight times the V will give you the weight, the force for the weight lah. Okay, in Newton. And this one is kilonewton because they give the specific weight in kilonewton. So you get the value for W, okay, which is 10.86. Okay, so your value for W, which goes down, is 10.86. Okay, now you want to find the FB, and another one that you have to know before you can solve the equation to calculate FB. Sama je, and similarly FB, you know, because they gave you again the specific gravity of mercury and 13.54. Okay, you can change it in rho, or you can change it in specific weight. Okay, that's why in here the FP equal to the specific weight of the fluid times the volume of the displacement. Sama kan, tadi cakap Archimedes principle sama dengan fluid yang kita displace. So that's why we have 9.81 times 0.125, and 0.125 ni volume lah. Okay, so we give you 1.23 kilonewton for your FB, buoyant force yang acting upwards, go upwards. Okay, so so you have this is for mercury, not this one, water. So this 9.81 ni for water lah, not because in this part A the concrete is immersed in water. So I'm sorry, the 13.54 when you want to answer the part B, when it immersed in mercury, then we use this the value. Okay, so you have the value for FB 1.23. Okay, so you can complete lah your equation to find Fe. W minus Fb, and W you know 10.86, and then you have Fb 1.23 will give you 9.63. Okay, now you know this value is positive, kan? Okay, now that means your assumed direction tadi yang go upward ni kan, so you assume goes upward and the value that you calculate is positive. That means the direction is correct lah. So that's your direction of the force is going upward lah. Okay, that's what it says here. Notice that the result is positive. This means that our assumed direction for Fe was correct. Then the solution to the problem is that an upward force of 9.63 kN is required to hold the block of bronze in equilibrium underwater. Okay, my question to you, from the start of the question, from the start of this, when you read this question, how you can determine whether the force is needed upward or downward? The force yang Fe tu, yang ni yang apa, yang kat sini, yang external force ni. Okay, from the question, how you know that we need a force which is acting upward? From the question, anyone?
The force required to hold
The
the
force
cube.
to hold the cube.
The force to hold?
To hold the
The force required to hold the cube.
Yelah, force tu dia memang diperlukan untuk required to hold, but that force can be downward or can be outward.
Submerge.
Submerge, okay, submerge lah, dia tak kisah. Dia macam mana, apa? How you can determine
Equilibrium.
from this?
equilibrium.
Equilibrium. Not correct. But you can still try. I give you the floor. Okay, satu apa, saya bagi hint lah, hint. Kalau objek tu dia punya density berat, density dia lower, compare to the fluid, apa jadi dekat fluid, apa jadi dekat objek tu?
Dia terapung.
Dia terapung, kan? Terapung, kan? Kalau objek tu lagi berat, maksudnya lagi the density of higher than the fluid, maksudnya objek tu akan
Tenggelam.
Tenggelam.
Okay, that itu common sense lah, semua tahu kan. Okay, so in this question they say that cube made of bronze, the specific of it 86.9. Okay, isi point saya 86,900 Newton per meter cube. Okay, what is the density of water, or what is the specific weight of water?
1,000.
1000, kan?
Yes.
Apa maksud dia? Apa dari
Tenggelam.
sini awak tahu apa?
Tenggelam.
Dia tenggelam, kan? Maksudnya kalau tak ada force yang akan lawan, berat tu akan tenggelam lah. Objek tu akan tenggelam. Kan? So dia kata determine the magnitude of the force required to hold the cube in equilibrium submerged. Maksudnya dia stay, kan? Apa maksudnya kita kena ada force lah, kan, yang akan lawan dia, betul tak?
Betul.
That mean the force direction is going upward, kan?
Yes.
Betul.
Itu yang saya cakap ni, daripada soalan ni awak dah boleh determine pun sama ada force tu dia perlu ke atas ke perlu ke bawah, kan? Because of this weight is larger than the density is larger than the density of the fluid. That mean we need a force yang akan lawan dia lah supaya dia kekal dalam submerge tu. Contoh untuk yang mercury pula, kan? Kalau dia bagi 13.4, kan? Okay, untuk B, how you can determine from this question whether the force is upward or downward? Ha, macam mana? Untuk merkuri pula. Hello? Sama kan? Ada ke tak ada?
Sama juga.
Ha? Sama kan sebab dia
Dia bagi specific gravity lah.
betul kan? Maksudnya we still need the force acting upward kan, because the bronze is too the weight dia lagi berat daripada, the density of that lagi berat daripada mercury itself. Mercury ni 3854. Ini kalau dalam ni 13,000 lah kot 13,540 kan.
300 lah.
Kan? So still larger lah, maksudnya yang berat bronze ni still lagi tinggi, that we need a force acting upward. Kan? Okay, if we to prove it, okay, let's assume, okay, so we do the number for number B kan. Okay, ni B okay. So dia ada dua senario. Satu, the cube would assuming cube would sink, and B assuming cube would float. So we're not sure yet. We're not sure yet how this force acting on this cube lah, sama ada dia akan ke atas ke ataupun dia ke bawah. Okay, so we just take both scenario. So we do the calculation. So this untuk jawab soalan nombor 2 kan. Nombor 2 dia nak find the magnitude and direction of the force required to hold the cube equilibrium completely submerged in a mercury. Okay. Okay, now they give you this two scenario to find this magnitude and direction of this force. Okay, in this first example, the left hand side A, so if you do the summation of force, FB, if you take the positive output is positive, okay, so FB plus FE minus W equal to 0. So this is for this one for A, and for B, for the right side ni B ni B ni A, okay. So for B, so you put the FE downward. Kalau you're not sure yet, you just play around and so the summation of force in vertical direction put positive. So FB minus FE minus W equal to 0. Okay. So FE, so for this you arrange back because you want to find the FE kan. So FE equal to W minus FB, and for this one FE equal to FB minus W. Okay. Okay, now you want to find sama juga macam part A tu, W equal to the specific of weight times V. So you know they give you the specific of the weight 86.9 times 0.125, the volume of the cube, they give you 10.86. So ni dah ready kan. Okay. And now you want to find the FB kan. FB ni dalam mercury. So this is for dia yang tadi tu saya selak dia tu kan. So they give you the specific weight of the mercury. So you can translate it to you can times the V, and you will find the F lah. Okay, 13.54 times 9.81 times 0.125 V will give you the buoyant force 16.6 kilonewton. Okay, so for part 1 yang kita consider the FE going upward, okay, so the FE will equal to W minus FB. So W is 10, kita kira tadi 10, and FB kita kira 16. So the answer is the value is negative kan. So take note of this, is negative 5.74. Okay, for the second one that we assume the FE is downward. Okay, FE equal to FB plus W. So we know the FB 16.6 minus W 10. So we give you 5.74. So this is plus. That means this assumption, the FE is going downward. Okay, is correct. Because the value is positive 5.74, and this assumption, maksudnya salah lah. Maksudnya the Fe must going downwards to make sure the cube is submerged in the mercury. Okay, so that notice that both solution yield the same value sama 5.74, but they have opposite sign. The negative sign for the solution on the left for the part 1 that we assume means that they assume direction for Fe in A was wrong. So the assumption that we say the Fe is upward is wrong. The Fe should be downward to make sure this cube is submerged equilibrium dalam mercury. Okay. Okay. So therefore both approach give the kalau pun awak kira macam ni, awak dapat negatif, so still correct. That means it just means that your direction is wrong, and you can just change your direction, which is downward lah. Okay. Whenever you try assume the direction is downward and you got the value is positive, that means the assumption direction is correct. Okay. So that's how you want to answer this question lah. Okay. Alright. Okay ke? Boleh? Okay.
Boleh sir.
Okay, so ni dah sebenarnya. Okay, we look at another example. No, apa satu. Okay. We look at the example. I think there's two more. Satu, dua. Okay, dua example lagi. Alright. A block is floating in water. So this is a block floating in water. So this ni level water dia. Ni level water. Okay. Figure 1. Determine the height h of the block submerged in water. Dia nak height ni je. If the height of the block extended out of the surface is 0.2. So yang tak submerged ni 0.2. So dia nak yang h ni, yang dalam air. So they just give you the density of the block is 780. Okay. While the density of water is 1000. Okay, 1000. Okay. So the length of the block is 1 meter. Ini 1 meter. And the width is 0.5. Kalau kira macam ni, ini 0.5. 5 and this 1. So dia nak panjang ni, h ni berapa? Okay. How we can do this? Okay, I try to show you how we can do this. Sama, we know we have draw your FBD. Okay, you have the weight go down. Okay, and you will have buoyant force FB. Okay, ni dia macam ni dalam water separuh. Okay, you might have whatever lah, up or downward okay, you don't know, but we're not interested in this pun because they just want to find the height the height of the submerged body. Okay, they give you the row of the block 780 and the row of the water you will know 1000. Right? Okay. Now, because it's floating, okay. So tak ada lah benda ni, tak ada yang ni, it's floating. So the FB equal to W lah, okay. The weight of the fluid, the weight of the block, and okay, and this you can translate in the rho GV term. So this is rho of the fluid, G V equal to for the weight, the rho of the weight of the block. I'll put it B lah, B, G sama, and V. Okay, so we can cancel out this G, but it's just the same. So we have row of the fluid times V and row of the block times V. Okay. So row of the fluid, they give you here 1000 times V. Okay, here is the interesting part lah. Okay, V dalam water ni, itu nak ni kan, yang FB ni kat sini kan, yang apa bertindak kat sini kan. Okay, who can tell me what is the V? The value of V inside.
1 times 0.5
1
times H
times 0.5
times H.
times H. Okay? Betul kan? Sebab dia yang interested yang ni lah kan? Okay. Correct? And we know equal to the row of the block, which is 180 times V lah. Okay, V ni apa pula? V untuk block.
Sir, nak tanya yang tadi kan yang dalam water kan, yang satu yang panjang dia nak kena tolak 0.2 ke tak?
Mana yang awak cakap ni?
Yang volume fluid dalam kan satu tu nak kena tolak 0.2 ke atas ke? Ya.
Tak, satu ni length yang ni.
Untuk yang
Ni. Ni satu.
Okay. Satu 0.5.
Satu lagi 0.5. Maybe the width lebar. Dia apa? Maybe yang ni 0.5 or ni 1, or maybe this 1 or this 0.5. Anda inilah apa? Length
so
biasanya yang ni length.
Tu untuk yang dalam air lah tak kacau yang atas 0.2.
Tak kacau macam mana, apa maksud awak Kan
tak, maksudnya
cube macam ni kan? Okay. Okay. Dia ada length, ada width, ada height kan?
Yes.
Height inilah 0.2 yang plus H ni kan? Okay, the height of the total block kan? 0.2 plus H kan? And they give you the length of the block is 1. The length maybe ni ikut length ni 1. And the width of the block is 0.5.
Oh, okay, faham.
Okay. So dia kita nak cari yang height ni, so tak ada kena-mengena pun lah yang 1 dengan 1/5 ni.
Okay, sir.
Okay. Tadi tu the volume yang cari dekat untuk buoyant force ni FB. So we know the row of the fluid 1000, and the volume that we interested dalam ni lah, dalam volume ni lah kan, dalam air ni. So that's why you said 1 times 0.5 times H lah bukan yang tenggelam tu H je. Kan? So this one must be equal to W, and this W is translate to rho GV is row of the block times the V, because we already cancel G sama. So now my question, what is the V of the block?
1 times 0.5 times 0.2.
1 times 0.5 times 0.2. Ada yang setuju atau tak setuju?
0.2 plus H maybe.
Kan dia nak value of the block kan? The weight of this total inilah, total volume of this block lah So maksudnya panjang ni lah, panjang keseluruhan lah. Faham tak?
Faham, sir.
So row of the block 780 times V of the block lah, V of the block which is 1 times 0.5 times 0.2 plus H kan? The height. Betul? Betul
Betul.
So now you
Betul,
have
sir.
the term H, ada H. So H lah yang awak cari H lah. Berapa H dia kat sini? Kalau awak susun kira-kira. Dia just mathematical lah 1000 kali 1 kali ni kali apa ni Cuba awak kira dapat berapa H? Dah dapat? Matematik je ni.
0.709 sir.
Ada yang dapat yang sama? 0.70
Sama je.
sama so this your answer for H lah. Dia nak cari H je kan? Determine the height H. So this is your answer lah, 0.70509 meter. Senang je kan? And it's very easy kan? So that's
Yes,
why
sir.
I'm not too worried lah about this topic. I'm more worried about the topic on yang apa? Hydrostatic force on curve tu. That's more complicated compared to this buoyancy lah. Okay. So we look at the example. Alright. 2 cubic blocks, oak and steel. Satu oak, satu steel with the same dimension. So the volume is the same. 0.5 times 0.5 times 0.5 are dropped into an oil tank as shown in figure 2. So the fluid is oil. Determine the amount of external force required to hold each block suspended in the fluid and the direction of each external force. So ni macam mana pula? Siapa ni? Saya macam biasalah. Siapa nak buat? Ada yang nak buat? Okay dah, apa? Ada yang nak buat? Ada volunteer nak buat? Nanti very easy je ni. Satu oak, satu steel.
Sama macam tadi kan sir?
Sama je macam tadi tu. Kita dah buat pun.
Kena assume yang ada dua arah tu.
Okay. So now, okay. Siapa cakap dia first tu?
Yes sir.
Siapa ni? Asal nama.
Daniel.
Daniel, okay. Okay, now we solve this one first lah untuk yang oak dulu, yang oak. Alright, how we can do that, Daniel?
Mula lukis FBD dulu.
Okay, good. Your FBD. Alright.
FB
kat mana? Bawah ni
FB kat bawah.
Okay, I draw the level of water lah so that we know this submerged in the apa? In the fluid kan. Okay, FB dari sini Okay.
Ada weight kat tengah.
Block. Going up ke down?
Down.
Okay. Next.
FE.
FE. Okay. What do you want to assume first? Upward or downward? Doesn't matter. It's up to you. Your FE going up ke going down?
Ni untuk oak block
Oak.
Oak block upward.
You want to, okay, you assume to the FE is going upward So like I said, don't worry about this direction. You just assume, you just put one in which direction and you calculate and find it whether it's correct or not. Okay, so your assumption is the FE is going upward at first, this is your assumption Okay, now what we do, Daniel?
The summation of
force,
FY.
FY, betul? Vertical 0. Okay.
FE minus W.
FE minus also W
plus FB equal to 0.
Equal to 0. Okay. And then
Rearrange.
okay,
FE equal to W minus FB.
W minus FB. Okay, good. Alright. And then find W W, what's the formula for W?
Rho GV.
Okay, rho GV betul. Rho GV. What's the rho?
The rho is 700.
700, yes. G lah 9.1. The V?
V 0.5 times
0.5.
0.50 times 0.5.
Dia cube lah Sorry, cube kat luar Okay. So what's the value for W?
The answer 858.
858. Is it Newton or kilonewton?
Newton.
Newton. Okay. So that's your W. And then you need to find FB. Kan?
Mm-mm.
So what is FB?
Rho GV.
Okay, rho GV juga. Rho of what?
Rho of water.
Is it
Oil.
water?
Oil.
Oh, oil.
Oil.
That's why I think the best way when you write the formula like this kan, W equal to rho GV, I think better to label this row what is row, and this is row for the block kan. So you just wrote row of the block. So that's you not confused and you not will do the mistake lah. So this one FB you said row GV, row this row I think better to label is row oil kan, because it's in the oil.
Yeah.
Okay, so row oil berapa? 580, 450. Okay, time G time V, V berapa?
V 0.125.
Sama yang ni kan Okay, 0.125. Okay. Okay, what's the value for FB then?
1042.31.
1042. Point apa? Point 3
.31.
31. Newton ke kilonewton?
Newton.
Newton. Okay, so you know you have your FB and you have your W. So now you calculate your FE lah. So what is your value for FE?
FE 858.37 minus 1042.
Okay, the value is negative
Negative 183.93.
Yes.
3.993
Yes.
Newton.
Newton.
Okay, so what does this tell you?
The assumption was wrong.
Okay, so the where's the direction should be
Downward.
downward, and so when you answer the question, you should change back. The FE should going downward, and the amount of force is 180. And so don't ever when you write your final answer, they ask you to determine the amount of external force required to hold each block. So it's 183, and the direction is downward. And okay. Oh, dalam ni dia tak minta direction pun kan. Dia tak determine the amount je kan. So tak apalah. Ke dia minta ke ni? Tak. Oh tak pun. Ada direction. So sorry. Ada juga. Tak nampak pula. So you need to label lah. So direction is downward. Okay. And the value is this. 183.9 Newton. Okay. Thank you Daniel. That's for oak. And for steel. Yang lain nak try pula for steel. Siapa? Next.
Fahmi sir.
Fahmi. Fahmi. Daniel dah suruh awak. Saya bukan saya suruh. Mana Fahmi? Hujan. Tak ada. Orang lain lah kata tu. Tak ada kata Fahmi tak ada. Anyone? Sama je step dia. Cuma mungkin lain sikit.
Saya rasa
Okay. Siapa ni? Ni Azib
Aiman.
Aiman. Sorry. Azib kan lain, kelas lain Azib. Okay, Aiman. This is your draw your FBD. How
First
FBD?
BD buat W
W
ke bawah.
bawah.
So FB direction dia ke atas.
Okay. I draw the ni level of water first. Okay. Alright. The another one.
FE ke bawah.
Oh nak ke bawah. Okay. Awak isi bawah Okay, no worries. Okay. Now write your ni lah kan. Question. What's next?
Summation of FY equal to 0.
Okay. Next.
FE
E.
negative FE
Negative FE.
uh,
Oh, okay. Awak ambil bawah positif kan. Okay, okay.
minus W
Ke atas lah. Minus W. Okay.
plus FB.
Plus FB. Equal to 0.
0.
Okay. Next. Rearrange this. FE.
Rearrange FE equal to negative FB plus W.
Ya ke? Ni awak bawa ke sana kan?
Negative FB minus W.
Don't do this mistake lah. Make sure betul. Okay. FB.
Next
W dulu lah, W.
find the W.
Okay. W sama dengan
Row GV. Row block. Row steel.
okay, row block. Steel, sorry, steel block row S GV. Okay, equal to
8050 times 9.81 times 0.125.
Okay, 0.5 cube lah Ada tak muat tulis. Okay. The value is
9,871.
71.
0.31 Newton.
Okay, that's your W. FB.
FB equal to row GV juga. Tapi row tu guna row oil.
Okay, row oil. GV. Okay. Berapa nilai?
Nilai dia
Sama dengan ni kan?
sama lah. 1042.31.
0.31 Newton. Okay. Now you can create your FE. Berapa nilai FE bila awak ganti balik? Apa?
Negatif.
Negatif berapa?
Negatif 8,829
29 Newton
Newton.
Okay, so what tells you?
Wrong.
Okay.
Because
It should be
it should be upward.
upward, and the FE should be upward. The direction of E and the magnitude is 8,829. Okay. So again, how you can know from this question your FE should be upward or downward from this value?
The bigger the value, the possibility to sink is higher.
Betul lah. So because of the steel and the value of the steel, the row of the steel 8,000 kan, and the row of the oil only 800. So in a neutral position without the force, the steel should Apa?
Pusing, tenggelam.
Pusing kan? Tenggelam lah kan? Kalau awak baling benda berat dalam fluid, dia akan tenggelam lah kan? In natural position. Without the force. Without the external force. So the still should be gone down, sink to the floor. That's why from the question you already know that the FE should be going up kan? Kalau nak maintain the still in the submerged equilibrium. Betul tak? Kan?
Betul.
So sama juga kalau dalam yang tadi tu oak. Kan? Because of this density of oak is 700 and density of oil 850, natural position without external force, the block should float lah kan? Dia akan float atas ni kan? Betul? Sebab dia lagi, the density is lower kan? Kan lower kan? 700 and 850 kan? So to make sure the block is suspended in the fluid, dalam fluid, tenggelam dalam fluid, maksudnya kita kena ada satu force yang tekan dia lah kan, ke bawah. Betul?
Betul sir.
Betul sir.
So from the question you already can determine the external force should going down or upwards. But if you cannot do like that, you also can calculate first. You just assume whatever direction, you calculate and you find the value. From the value you know your direction should be in what direction lah. Okay? But just for our learning, you already can know it from the value of the density. Benda yang berat, density dia daripada air tu mestilah dia akan tenggelam. Benda yang lagi density lagi rendah, dia akan terapung kan. Itu simple lah buoyancy. We have dah habis dah. Okay, I think that's all lah for buoyancy kan. It's very straightforward I think. Like I said, I'm not too worried. I think you can all do this. You can all do this problem. I will try to find more example, more tutorial for buoyancy, and you can do it lah. You can do it on your free time, and just to master your understanding in this topic, buoyancy. Okay, any question again?
No, sir.
Yeah?
No sir.
Okay. If you don't have any more questions, now is 1:30. Okay, I think we can. Let me stop the